Good afternoon, everybody, and welcome to another Geo-Institute live stream. My name is Brad Keeler. I'm the director of the Geo-Institute, and welcome. It is election day. It is the opening of college basketball in America. It is so many things this week, and you have taken time out of your busy lives and schedule to join us for GEOSTRATA Extra. We are, of course, featuring an article today from the latest issue of the magazine on geostructural engineering. If you haven't read it yet, I would urge you to do so. You can pick up your paper copy and leaf through it. Left to right is the preferable way to do that, or you can read it at readgeo.com in its electronic glory. If you don't know anything about the Geo-Institute, after you watch this interview today, head over to geoinstitute.org. You'll find out all kinds of things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, now that you can see stuff and you can hear stuff, you should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Now 100% more audible than she was before. Here to run this interview today, all the way from the great state of Maine, it is Mary Nodine of the Federal Highway Administration and one of our esteemed editors from GeoStrata. Mary, now you may do your very important Election Day quiz.
Okay, so this is my Election Day quiz. I actually pivoted it, but since I am in Maine and it is Election Day and the project we're going to talk about is also in Maine, I'm going to do a quiz for all the listeners. So there are 2 states in the country that do not give all of their electoral votes to the popular vote winner. And one of them is Maine. And what is the other one? So Brad, let the answers roll in, and I will start introducing everybody, but
am I disqualified from answering? Because this is a softball.
Just had some Maine trivia. We can tell people they can't look on the internet, but anyone who looks on the internet, we're just teaching some people something here. Okay, so I'm going to move on. Welcome to the latest episode of GeoStrata Extra. In this series, the magazine's editors, that's me, interviews an author of an article in the most recently published issue. Today, we actually have 4 authors, which is the most we've ever had. So we use these sessions to delve more deeply into one article and get the author's added insights on the article and the overall theme of the issue. As Brad said, I'm Mary Nodine. I'm a geotechnical engineer with Federal Highway Administration, and I've been a GeoStrata editor for about 8 years, and I've also been the resident geopoet since 2008. Today, I will be speaking with David Finocchio, Drew Floyd, Giuliana Zelada-Tumialan, sorry, Giuliana, I didn't practice that one, and Zach Boswell, who co-authored the article, Threading the Needle, Redefining Earth Retention for the Maine Medical Center. This article was featured in the October-November 2024 issue of GeoStrata that focuses on geostructural engineering, and it tells an exciting story of building earth retention on an active hospital site, with challenges ranging from lifeline utility infrastructure to tieback installation inside an active parking garage. Before we dive in, I will briefly introduce the authors. So David Finocchio is the Director of Business Development for Keller North America. He leads a business development team focusing on strategic growth, building business partnerships, and fostering client relations. Drew Floyd is the Vice President of Grouting with Keller in Rockaway, New Jersey. He's responsible for managing Keller's Specialty Services Grouting Division. Giuliana Zelada-Tumialan is an associate principal with Simpson, Gumpertz, and Hager in Waltham, Massachusetts, where she is responsible for project oversight and management, and she has expertise in design, investigation, risk assessment, and mitigation strategies for geotech and below-grade works. And then last but not least, Zach Boswell is a senior consulting engineer with SGH in Waltham, and he's responsible for geotechnical design, managing projects that include new and existing foundation systems, supportive excavation, retaining walls, and many other below-grade works. So if you have questions for the authors, I encourage you to type them right into the comments for this video while you watch, and then Zach will make sure I get them and see them, and we'll do our best to address them. Sorry, Zach, not Zach, Brad. We'll make sure that I see them, and we'll do our best to address any questions as time allows. So welcome, David, Drew, Giuliana, and Zach.
Yep.
All right, so let's dive in. The first thing I wanted you guys to do was just provide some background, and this question I guess is for David. Just provide a little background on the Maine Medical Center's needs for this project and how your retaining wall allowed the hospital to accomplish its goals.
Sure. Can you hear me?
I can. Do you want me to share photos while you talk about this?
If you want to show on, just high level before you do. Thank you, Mary and Brad, for the stage here and for giving us some time. This job started a number of years ago, back in 2018, so it's been a long time. A lot of this work happened during COVID, and we didn't get to see it. So really appreciate the stage at this point. And back to your comment that there's 4 of us on it. I can't understate the amount of effort it was to build this wall with a collaborative team approach. So as shown on this photo here, I think the picture is worth 1,000 words. The need that came from this development with Maine, which was ongoing renovations over many years, was to cut into that slope. And there was an existing garage that had to be demolished and that wanted to stay in service as long as possible, which is why we were called in early. So the need arose from the challenge of, operationally trying to keep this hospital operation parking as long as possible, while at the same time cutting into a slope that, revealed 70 foot of earth that had to be retained with that building right behind you. So I'll leave it at that and maybe ask the other team members with Giuliana and Drew. But at the beginning, my involvement was really just, listening, napkin sketching, and trying to figure out how we're going to solve this problem, putting the right team together. So maybe, Drew, you want to jump in, you and Giuliana and Zach kind of jumped in with that.
Sure. My involvement was probably somewhere around 2017. And, we had looked at the project from a bid standpoint with another contractor. I came from a different company that ultimately was acquired by Keller. And lo and behold, I was able to work on the project. And we had a lot of upfront design meetings with Simpson, Gumpertz, and Hager at their office. And it seemed like every other week we were having another meeting. And I remember some of the constraints that we were given. Oh, we don't have enough room for this, or we don't have enough room for that. How big is this? How big is that? And we really had to figure it out and break down to the nitty gritty. And so there were a lot of things that went into the final design, and we didn't have interest to spare. So I'll let Giuliana talk about that part of it.
Sure thing. Thanks, Drew. And thanks, Mary. So SGH actually has been working at the Maine Medical Center for several years. Actually, back in 2008, I was working with John Thompson, who's one of the principals that does most of the structural work here with the hospital, on another supportive excavation that was about 60 feet deep on the visitor parking garage, which you see on your left right now on the screen. So SGH has been doing work at the site for a long time. And as part of that, we were already the structural engineers for the design of the new building that's going to where the excavation is. And that's where, all the meetings that Drew was part of with the design team for the building. They knew they wanted the building there. It was a matter of figuring out how to get that excavation supported, as we said, with an operating main surgical building behind us. So that's when I got involved, I'm going to say late 2017, early 2018. We have a geotechnical team here at SGH, and John Thompson, like I said, we've worked before. So as we're going through all the constraints, the site constraints, the limitations, some of the complexities of the design, John approached Bill Konicki, who was my mentor, is now retired, but at that time, he was one of the principals here and working with me. I was acting project manager and lead engineer overall for the permanent supportive excavation. And that's how we got involved through our structural engineering team here, having a complex issue that we love to solve. And so we got together and like David and Drew mentioned, in a very collaborative way from the start, getting the contractor's point of view to feed into what we were coming up with ideas for design and how to go about it. That's basically how this developed.
Awesome, thank you. That's some good background on the project. Brad, how'd the trivia question go? Did a bunch of people get it?
No one is playing your game, Mary.
No one's playing my game. My goodness. Can we offer a prize to the first person who gets it?
Only if they're in the US or Canada and I can send it to them.
All right. Brad will send you a prize if you type in the correct answer to the state besides Maine.
Hint, it is a Midwestern state.
The state besides Maine that splits their electoral votes. Okay, moving on. So this is the most people that I've ever had on a GeoStrata Extra interview, or that we have ever had. I also interviewed 3 people on my last one, so I'm a little worried about what's going to happen in the future in terms of this trajectory. But I know you all work together, and I'm wondering if you could describe your individual roles and how the project team worked together during design and construction. I guess I'll start with David again on this, but each of you is welcome to chime in.
Sure. Thanks for that. And this sounds a little bit redundant, but tell them what you're going to tell them, then tell them again. So yeah, my involvement was really early stage and working at the front end when the need came up for us to weigh in as a contractor's approach to how we're going to build this project, given all these complexities. So the early stage involvement, kicking around ideas from napkin sketches to looking at all the different possible solutions and bringing that to the team in PowerPoint slides to try to educate the whole team and what are the options, the various options. Of course, with earth retention, there are so many. And we kicked around probably 10 different ideas and how we're going to do it. After that need became apparent, we got a closer collaboration. That's when I worked with our Keller team and put something in place so we could work more actively on a week-to-week basis. That's where Drew came in. But then throughout the project, so I somewhat dialed out, but stayed involved through COVID and setting up, the photos for this project, for example. But our team stayed involved to make sure we saw it from, beginning to end, to tell a good story. So I'm really appreciative of the team to support the details. I wasn't as involved in the technical pieces of it throughout, but certainly the documentation and telling this story is what our team has done, including, Full Circle being able to share it now. So maybe I'll turn it over to Giuliana and Drew for a little more details.
As I mentioned before, I was the project manager for this, as well as the lead engineer. So we had all the geotech and structural engineers, all the drafting under, and then participating in all the meetings. My involvement started late 2017, early 2018, and it went through the end, through full completion of the not just the construction of the SOE, but throughout the end of the monitoring that was done after construction while the new building was being constructed itself. True? Yeah,
I mean, a lot of the context of those meetings that we had, the collaborative meetings, we hashed out details, like I said before, down to the inch. We only had inches to play with between the new wall and the structure, if you will, and how do we accomplish this within this amount of room? And by the way, we've got to thread these tiebacks through an existing forest of piles that were installed in a building adjacent to the site. And how do we keep ourselves from getting in trouble by drilling through them. So, most of my involvement at that point was constructability and design, although SGH was the designer, had a fairly decent design background. So we were able to hash things out as time went on.
Yeah. Awesome. Yeah, I mean, I know from experience that these kinds of really complex projects involve really close collaboration and creativity between the contractor and the engineer. I think this is a great example of that. So The system of supporting the existing parking garage, as you can see in this picture, we can show some more pictures to the viewers who haven't kind of delved into the article, but the system of supporting the existing parking garage wall with a new overlying permanent wall was really interesting solution. So my understanding from editing your article is that you had an existing parking garage in here. I don't know if we have photos of the original conditions, and then you put tiebacks through that existing wall and kind of covered that wall over with a new permanent wall before demolishing the parking garage. Can you tell me more about the concept for this and how it was developed and any specific challenges that you had drilling tiebacks in that operational parking garage? And I will scroll through the pictures now and sort of show some of those.
Except I think we've lost some of those photos. We've lost video, guys.
We've lost just the slides or us too?
There's nothing.
Oh, I think the problem is with the slides.
Do you want me to keep talking or do you want me to, we can go with that video for a little bit.
I think Aurora, do we know what's going on? Okay, Amber will come back and I don't know what the best thing to do here is.
This has never happened before, guys. So it's been perfect.
Have you done the slides, like switching between slides? And
we're back on.
Great.
Okay, let me get my screen back up. Slides. All right. So we're good, Brad?
I don't know. I'm watching yeah, we're good.
Okay. So yes, the existing parking garage, the concept was that here we have this existing parking garage. So we do have existing conditions photos. You can see it here in plan. And this was the back wall along which you were drilling your tiebacks and putting in your new wall. So the question was, what can you tell me more about the concept for this? And I guess I'm also curious, like, were there other ways you were thinking of doing the SOE? And then what challenges do you have did you have with drilling tiebacks in that operational parking garage?
Sure, I can start with the
go ahead.
Concept for it. So for the new building the new building is going to be the new phase of Maine Medical. They wanted a very prominent location, which was going to take and replace that employee existing garage. When Drew mentioned the limitations in space, the back wall of the new building was really within 1 foot, if you will, of what would be the line of the SOE, of the final SOE. So there was not much room there to work with for tolerances. And when you look at, if you go back to the original photo that you have with the view of the wall, once you had that garage, that wall was maximum 40 feet tall, the existing south wall of the garage. The main building of the hospital was within 40 feet behind that wall. So demoing that existing wall was not really feasible if we wanted to maintain the stability for the hospital, plus all the utilities. And it's not just any utility corridor, it's really the trunk, the livelihood of the operation of the hospital going through that utility corridor right there. So not much could be done there. So using the south wall, not demoing the south wall and using it for support was about the only way that could be done. Having said that, we were going 80 feet deep, so the loads that wall was going to sustain were much higher than what it had been designed for. Right. Not only that, but that wall was, in service since the 60s. It was a parking garage, so there was some deterioration, not just to the concrete, but even corroded rebar. So the capacity of that wall was limited. We did an extensive investigation to determine what the existing conditions of the wall were, and what capacity, what kind of loads, tieback loads the wall was adequate for. We concluded from that this could only be a temporary facing. It would only be able to sustain loads up to the excavation to the top of the footing, to the top of the footing. And not only that, but even just to sustain the loads of the tiebacks, we had to spread the load on the surface of the wall quite significantly. And we were using some 3x3 steel plates that had to be installed. All of that just to take up to 40 feet of excavation and be able to be stable. In order to be able to go down another 40 feet at the maximum depth, we had to figure out a way that we could install a new permanent facing that could perform as a permanent facing and be able to increase the loads on. And that's when the installation of the new concrete wall in front of it came up. The idea of extending the heads through the concrete wall with a threaded bar and then retensioning to the higher loads in front of it. I remember conversations in those meetings and then also on the phone with Drew trying to figure out, what's out there in the market that we could make that happen. We came down to the threaded bar and we looked seriously into it. What could be any pitfalls? Were we going to lose any load, or was there any possibility that it would get them fastened, et cetera? That's how that came up. The next thing after that was how do we connect both those walls to the second wall that we ended up installing at the bottom. That was, again, another complexity to work through. There was, that retaining wall had a footing, a wide footing that extended about 7-8 feet in front of the wall. In order to make room for the secants, we had to saw cut that existing footing. That in itself entailed some potential instability that we had to deal with. Then install the secants and then figure out how do we connect the top of the secants to a new pile cap, to the wall. It ended up being that basically the front of the secant wall ends up about 3 feet in front of the permanent facing wall. So you do have some moments to take on. For that, we had to double in the rebar and just, make it all work. So cutting the footing itself while maintaining its stability, that was done by the general contractor. That was also pretty intense as far as trying to figure out what kind of saw cut to use, how it would be done within the constraints of the site. So a lot of things to think about, even just from how to build the wall itself in its place. Talking about the tiebacks, I may be going ahead in some of the questions and now you have ahead, but for the tiebacks, it basically comes down to we have a critical structure behind us. We have to do all we can with our due diligence to identify where these utilities are, what kind of foundation, the hospital is on both shallow foundations and pile foundations. Depending, the west end is on shallow foundations, the eastern 2/3 is on piles. So we basically model it all in BIM, in Revit, actually, in 3D, and we model everything so that we could locate the tiebacks, and I call it play with the tiebacks and the angles of the tiebacks. I've never played with angles of tiebacks like I've done for this project before. One thing is to play with the vertical angles, but we played with the vertical and horizontal angles, trying to make sure that we were threading through piles, making sure we clear utilities. There were a few tiebacks that were definitely threading the needle. I'm amazed that we were able to, this project went so smoothly without really hitting anything. At least on paper, I know that we were, we had the typical shot where you have a batter pile and a vertical pile, and you had about a foot of space, and you had one tieback going right smack in the middle there. Zach and Andrew can talk more about what we did that in the field to do the quality control on that, but it required, and I think the one thing that I'm most proud of for this project, for everybody in the team, obviously too, the design team, is the due diligence and the planning. We really went out of our way to make sure that whatever single document of installation, of temporary sheeting that was in that corridor, of utilities, of piles, anything that you can think of that could be obstruction or could derail this project, we wanted to have it in the Revit model and make sure that we plan ahead. That was one of the things we did, and then of course we did a very diligent, evaluation and assessment of what the potential movements of that SOE could be, what would be the impacts on the hospital. And we developed a really detailed tracking of the surveying data and the movement monitoring program once that went into construction. So now that was a long reel. I'll leave it up to Drew to talk about the tiebacks a little bit more with the operating parking garage. But yeah, that was a lot of work there.
No, that was a great overview. And I mean, looking at this model, you can really just see how complex it must have been. In terms of delivery, I can see you incorporated it into the Revit model. Did you still have all that information communicated on paper plans for the contractor, or did you have other means of communicating the specific tieback information to them?
Oh yeah, we definitely produced a package, a drawing package for the permanent SOE with tieback tables, locations, angles, and everything else in there that they would go through, and that's how they would survey the location of the tiebacks on the walls. And all the cross sections were from the Revit model. We added, if you know Revit, sometimes those cross sections don't translate as well as you want. So we did have to do some tweaking here and there to make sure that the right information was getting across. The Revit model got to the contractor, of course, to do other conflict checks. But between the model and what we had in paper, plus I could not stress this too much, plus all the constant communication and coordination between the entire team.
Yeah, for sure. I can imagine. I think you answered a lot of my design questions, but one thing that didn't come up is the article mentioned a soft sensitive clay stratum that was found in one area of the site. And I'm curious whether, I know that, the configuration of everything was a big challenge, but was that or other geotechnical conditions a particular challenge for the project?
I would say that the main thing that did for us, working within a design framework and having to meet code, specifically seismic code, the clay is a very sensitive clay, natural to Maine. I always keep forgetting the name, and Zach just told it to me before the meeting, and I already forgot again. So Zach, if you can go ahead and say the name of it. It starts with a P, I believe.
Presumpscot.
Yeah,
there you go. I can never pronounce it either. But the most important thing about it is that it's a very sensitive clay. You can see blow counts, say, of 5, but in reality, as soon as it gets drilled through, it can lose a lot of its strength. So, and that was particularly impacted the eastern end of the site of the wall. So a lot of stability analysis that had to be done, especially in the temporary condition. That's really mostly what it was, plus some of the seismic design and the estimated movements during seismic event and providing the right clearances for everything to move and not be hitting each other. That's really where that came up. I believe those were the longest anchors too, the longest tiebacks that we had to do, right, Zach, Drew? I believe that those were, I'm going to say probably 180.
180, almost 200
wow.
feet.
Yeah. Okay, so
and
you
that
did
was
have
just
to consider that. Yeah. Okay, yeah, thank you. I think I want to dive in now to the construction challenges related to the tiebacks, because we have some interesting pictures there. So I don't know if David or Drew wants to jump in and talk about that. Let me find the photos. So here's some tieback drilling.
Yeah, these are just illustration. The first two, I'm sure most folks on the call know secants and tieback. So Drew, I'll turn it over to you. Just show you some of the real life working conditions and things that we had to.
That's good right there, Mary.
All right.
Yeah, so I remember talking to the operations manager. He says, "You want to do what? In how much headroom?" So you can kind of see we had, the existing slab above us, the slab below us, and we had to kind of shoehorn the drill rig into that. If you look closely at the photograph, the drill is actually on a little bridge. So we had to bridge from one beam to another, and work in this headroom. And so everything, like the tieback anchor tendons, it came coiled in a horizontal uncoiler. So you're trying to work with a 100 and, well, at that point it'd be 200 feet long with the pigtail in this headroom, and pay it out into the casing, and then grout it, and then pull the casing out. But there are a bunch of things that happened kind of before we even got to drill. Giuliana didn't mention that the wall for the building was not plumb. And so every anchor had a vertical consideration. So all these holes had to be cored at different angles to get the correct azimuth and the correct location. And then when we were drilling the anchors, we were using downhole gyro instruments. So we would drill to within so many feet of what we perceived to be a strike, either for utility or a strike for a building pile, and then assess where we were in real space, and then determine if it was okay to proceed along that path. And Zach, you can kind of explain, every day we started out with a chalkboard and went through all the little nitty gritty of each anchor.
Wow.
Yep. Yeah. So it was, at the beginning, we used that Revit model, and as Giuliana touched on quite a bit, so that we established a series of obstructions at every single tieback across the wall. And then based on that, to what Drew was saying, is they had a sit down every morning, went through the tiebacks they were going to drill, said we are anticipated encountering these known obstructions, whether that's a sheet pile, an abandoned sheet pile, potentially, or other abandoned, remnants we were having to drill through. There was a small retaining wall on the other side that we had to drill through. So understanding where those were critical for them to know that while they were drilling, if they hit something, is it something that we were anticipating? Was it something that we're not? Is it to help determine if those were boulders, or if it was, if it could have been a foundation element for the building across the way? And we had a lot of checks with that, and that was just the first one. And then to what Drew said, each one of these tiebacks were surveyed onto that wall, and we were keeping that as tight as we can, and the surveyors would survey those tiebacks. They would get cored out, they would get prepped to drill, and using that information on some of the more critical ones where we were really threading that needle between, battered piles for the building behind the main surgical center. We would use that gyroscope, which was a nice survey tool, because you could collect survey information downhole in the tieback itself, and we could take that data and put it into the Revit model, and we could project the path of the tieback in real time. And so at some of these critical tiebacks, it was fantastic. Really, it was a great piece of equipment.
Some good technology.
It's something that's used in oil and gas quite a bit, and I had a little bit of experience with that with my old job. We get that information, and as we're getting it, we're uploading it directly into our model. We're looking at the model, we're projecting it out, and we're seeing, like, is what we're wanting and is what we had on plan what we're actually getting. And we were like, it was pretty impressive. I mean, there was a lot of checks to that, besides surveying and all the tiebacks. I mean, these poor guys, these drillers, I don't have a lot of envy for them at the moment, because they had to set that up perfectly. They bolted their rig into the ground. You can see it in this left photo here. They chained that rig down so that it didn't move as they were drilling it, because we were going to go through steel sheet piles, and we were going to go through some reinforced concrete in these. And so we didn't want that rig to move or wander at all. And then there was everybody would review this information, sign off on it, make sure we were good to go. When we were at some of these critical ones, we were on the phone continuously, making sure that we were getting these in the right spot, and it was highly successful.
And I think we have to give kudos to the drillers too from Keller, because as you know, in the planning and the design, when we were talking about how to rate the risk of hitting something, and we did +1, -1 degree cones, and we did +/- 2 degree cones, with the +/- being what we typically would use in any specification. But when you look at the gyroscope data that we got from the drilling, the Keller drillers, well, I mean, if there was perhaps some slight deviation, but it was like inches, like 1 inch or something like that at most. So it was almost perfectly following the path, which definitely helps.
Yeah, and you never had any incidents of hitting anything on the whole project, or were there any issues?
No, we didn't have any, we didn't hit any foundations. We moved a couple of tieback heads based on seeing some existing conditions, but we were fortunate that we didn't have any major issues like that.
We had one surprise.
Yeah, we had one surprise, but that was, so the tieback work went smoothly. What was it when we did the core, right? We did the corings through the wall for some of the, for installing the tiebacks at the start. And in some of those cores, we found a utility that, to our understanding, was not supposed to be there. So that forced us to, in that area, to go ahead and relay out the tiebacks to avoid that utility. One of the things that worked in our favor in that area was that because of the permanency of this service life for this supportive excavation, and with the hospital being a critical structure behind us, we had some redundancy built into the tieback load. So we did have some flexibility to move around tiebacks without necessarily changing too much on what the tiebacks needed to be. It obviously ate a little bit into that redundancy. It kind of reduced it, but it was there and it actually played in our favor.
Yeah, wow. So that original issue, that was when you were just coring through the wall, so it was something like really close to the wall that you found, the electric line?
Right.
Yeah, that's really, it's all pretty remarkable, and I can just only imagine how much detailed work that was for everybody. So I know the wall had an extensive monitoring program which showed that it performed well and in accordance with the design, but I don't think the article talked about whether there were stringent movement requirements related to the hospital for this project setting. So I'm curious what you were targeting for movement and how you guys did with that.
We did a lot of modeling and we used that. We made a model to help us predict the movements, and then using that information, we then set up a very extensive movement monitoring program where we started this, and Giuliana touched on it, from the very beginning, before even putting the first tieback in place, all the way through until the building was not substantially complete, but the foundations were in and they were starting to, build up and backfill around certain areas. And then based on that, really the majority of the movement occurred during the initial tieback installation. And that, we changed, we worked with Keller to change maybe a few installation procedures, and we saw that the movement really was abated, but we didn't have as much, I would say, stringent movement monitoring criteria, the typical like threshold and limit value. We based it on all our predictive modeling and, seeing what we got in the field and doing more of an observational method in that. Where we had tighter tolerances really was the installation, keeping the CCAM piles as plumb as possible, because again, that a lot of the wall wasn't plumb, and then there wasn't a lot of space between the new building and the CCAM wall that we had. So we couldn't really eat into anything on right. Both sides of it. So it was, I'd say, maybe more stringent installation tolerances than movement monitoring.
Yeah, I think one of the things that play into that, Mary, is that, sometimes when we're doing traditional SOE, we don't know much about the existing buildings. And so you tend to be conservative putting a threshold value, limit value within bounds 1 inch and so forth. With this project, it's an 80-foot deep excavation. A lot of it is on till, and actually during construction, we found out the till was better than anticipated. So that actually also helped to control the movements on the wall. Mm-hmm. But before we did it, we did the FEM model and we did the manual correlations that are out there just from experience with the SOEs and the depths and the stiffnesses. But the key thing is that we went through projecting what the movements would be behind the wall all the way to the second, third row of piles in the building. And along the length of the wall, we evaluated all the distortions. We went ahead and also color-coded. So similarly to how we color-coded the tiebacks, we color-coded areas within the hospital where we thought there was going to be the most distortion. I don't know if you remember, right? The western side of the hospital was in shallow foundations, the eastern 2/3 on piles. So we knew there definitely was going to be something to look out for there. Mm-hmm. Luckily, though, the western side is the shallower side. Ultimately, of the site, the deeper one ends up being around the middle. But we again, it's just the planning and the due diligence paid out significantly in this case, because we could have gone an easy way of trying to limit the movements to something tight. But I think even all the already tight situations here, that would have limited what the contractor was able to do more so than help.
Yeah. I'm just kind of scrolling through pictures, so anyone who wants to comment on anything, go ahead. But we're getting relatively close to the hour, so I want to make sure to get to my last question, which is, I would love if each of you could say your most important takeaway from this project and what you learned from it that you'll apply to other projects, and we can look at this beautiful picture of the final Malone family tower here.
Sure, I can start. Just quickly, I appreciate the team and everybody here. I can't articulate enough the complementary nature of the whole team at all points of this. It really was one of the coolest projects I've been involved with in my career. Really, really good team, and just the communication, the coordination all around. Especially, and thank you, Zach, for that note about the Keller team. We're very lucky as a former consultant myself. I can't say enough about the team that we had in place to execute this. So there's probably over 50 folks from Keller that touched this project in the field. So I'll turn it over to Drew, maybe articulate a little more than that, but really just a really wonderful project. Thank you.
Thanks, David. The collaborative nature of the job certainly, probably a number one comment. But, there were a lot of technical challenges. And, for me, the gratifying part was, I remember going back and forth with SGH on how much room should we allot ourselves with the tiebacks at the distal end. And we went back and forth for what seemed like months. And it's like, and then they said, well, how are we going to measure this? Gyroscope. And then they wanted to do every hole. And I was like, oh, here we go. But, honestly, I'm amazed that we were able to do it as I'm amazed that it turned out as well as it did. It was a risk. It was a real risk. And, I can't even imagine what would have happened if we had encountered one of the piles. We took a lot of time and effort in trying to make sure we were true and whatever we could do to prevent a strike, and it paid off. So that was, for me, very gratifying.
Yeah, I mean, now it probably, I would imagine it builds confidence for being able to do similar jobs like that in the future for you guys. So that's pretty awesome. How about the SGH folks?
I'll let Zach go first.
So collaboration, we've said it a bunch, and that's really true. And then the other big one is being able to adequately explain, risk to, building owners and clients, and understanding of not everything is just simply easy and it goes into place. There's a lot of things that you have to consider. And obviously with a project as complex as this, there was, and I certainly wasn't part of the majority of them, but the ones I was, being able to explain the risk of what we're doing here and having them buy in and get that acceptance is critical.
Yeah, good one. That's communication is a good lesson learned for sure. Giuliana?
All of the above. And but I'd say for me, it wraps it up into, depending on the complexity of the project, there's different levels, but the due diligence and the planning and the willingness to bring in other people's opinions into the table and be able to, as a designer, sometimes we want to go with our own ideas and just keep going. But this type of complex project is you have to be open to, some alternates that perhaps you wouldn't have thought of. Coming from SGH, as you are aware, we do a lot of investigations, so my investigative nature is always there, but this has to be one of those things where due diligence definitely plays out. The planning, being able to do a detailed and exhaustive planning, bringing in the owners, bringing in the contractors, bringing in the CMs, it all just paid off.
Yeah, it's worth the effort, even if it seems like overkill at the time sometimes. All right, awesome. I really appreciate you guys' time. My last little question is, I don't think any of you are from Maine, and as I mentioned, I live in Maine. I actually grew up in Portland, and I'll show you guys. You can almost see in this picture the house that, sorry about all the scrolling, I don't know how else to do this, but back in here is the house that I lived in high school and that my parents owned almost just until a few years ago, actually. And so when I would go visit them, I would drive right up this street and watch this wall go up, and it was pretty fun to watch. So I'm curious, I don't know how much time you guys spent on site, but I know some of you were there a lot. So do you have any favorite Portland experiences or restaurants or memories of being in that area?
Many. Many. Salvage Barbecue was across the street. That was always
I was just going to comment on that. Right, you can see it in the last one.
That was the go-to place. That was the go-to place every time we were there.
Yeah.
Yeah.
There's a lot of great restaurants and breweries and everything in downtown Portland. I go up a couple times a year just to go up.
Right there.
Mm-hmm.
Yeah.
Yeah, I found Thompson's Point and hadn't been up there. But got to see a concert with my wife now that we're empty nesters. So it's good. It's good to get out. Yeah. A lot of good food trucks.
Yeah, that's awesome. Good. I'm glad you enjoyed Salvage Barbecue. I was looking at this picture as you were talking and thinking, I bet they took advantage of that convenient location. Tandem Coffee is a super hyped up bakery that's around the corner up here. But when I get a chance to go there, I go there because my breakfast.
The line is always too long there.
It's too long, but if you are
Holy Donut's a good backup.
What?
Holy Donut's a good backup.
Holy Donut is awesome, super awesome. Yeah, but we frequent those whenever we live way up north, but when we have to drive through Portland a lot, and both of those get a lot of attention from our family.
You have two James Beard bakeries in town, miles apart. I mean, that's pretty rare. Zoo is one of them, and I can't remember the other one, but yeah, they're two 2024 James Beard winners.
All right, I'm gonna have to check those out too. Yeah, growing up there, the food scene there has just exploded since I've been an adult, but it's pretty crazy. But yeah, that's a fun place to get to. There's worse places to work, I guess. All right. Well, with that, I'll hand it back over to you, Brad. I really appreciate everyone's time. It was fun to interview you and fun to work with you on the article. Oh, there's a couple questions. I wasn't looking at the questions.
We did have a couple of questions, so we can go to those real quick if you want.
Sorry about that. I was sharing my screen, and like I predicted, I didn't see them. So Nick Burkholtz asked, how was heave or bottom stability considered? And so I guess that's a question for Giuliana or Zach.
Oh, Zach probably remembers all the stability analysis that we had to do to make sure to figure it out. So I think the most critical part was on the side where the clay was. But we were lucky in a way where in the temporary condition, the clay was sufficiently below the bottom of the footing of the wall with another layer in between that we were able to deal with it by controlling or limiting how much overburden the contractor was able to remove. So we always asked them to keep a certain amount of fill on top so that, the wall was advanced in, I think it was 25 feet sections, more or less, true, right, Zach? So we kind of control it that way, just making sure we had enough weight on top. And then once the second wall was there, the second wall and the tiebacks, that took care of it. So the clay was not an issue anymore at that time.
All right, awesome. Thank you. And then the other question that we got is from Ricardo Suarez. After this experience and knowing what you know now about this project, is there anything that you would do different in the design or construction aspects? That's a big question. But does anyone have any answer?
I haven't had another project this big to really implement anything differently.
Yeah, this is the benchmark, right? Haven't done a lot of guided tieback projects.
I'm trying to think about it. It's easy to say once you see how something performs, but when you are in that design phase, you don't know how things are going to perform, and you've got, not everything is going to be critical. I understand it, but in this particular, we did have a hospital that had to be kept under operation, surgeries, even from a vibration standpoint. That was another thing we haven't even talked about, but for a time there were everybody was worried about, are the doctors going to be able to operate? The utilities, the space, keeping the parking garage in function, in service for at least a phase one. So I would like to say, like a typical geo, I would like to have much more information on the soils. I could have, fine tune a little bit more, perhaps not be as conservative. That's always a desire everywhere. From my side, at least, honestly, if I think of something, I'll let you guys know. But I think at this point, it's seeing things after the fact. It may not be necessarily realistic when you're in that design phase, and you got to work with what you have.
Yeah, that's how it goes. But you mentioned that the till was actually you guys were conservative in how you considered that. So it's like maybe if you'd done more testing or something, who knows, you could have been a little more.
Yeah, so some of that is
streamlined.
So we did very limited. Obviously, when we got there, there's so much built environment that getting to do additional borings was very limited.
Right.
Especially, we wanted them inside the garage, which is where we would love to have had them, and that was not necessarily that feasible. But the hospital does have a geotechnical engineer, and we work with them too, hand in hand. So they provided the design parameters. Ultimately, we review it, but we were making sure that, again, everybody is a team here. The owner has their geotech engineer. We are EOR for the SOE. Keller is building this wall. Turner is managing. So everybody had a role in it. So could more data have helped fine tune? Yes, but how realistic is it to actually get it?
Right. That just occurred to me. Like, were the borings that you did between the two buildings? Or did you work with?
Yes,
okay.
we did the borings basically for the inclinometers so that we could install inclinometers in that area.
Yeah. Okay. Yeah. And I'm sure you had previous data from the old construction. Yeah. I can see why that'd be hard. Awesome. All right. I think that is a good way to wrap it up. I really appreciate Nick and Ricardo. Thank you for your questions. And I appreciate everyone who watched. This was fun. And go ahead, Brad.
We made it through all the no audio, no video. We persevered. Same for our viewers. Thanks everybody for sticking with us today as we pushed through the technical difficulties and heard about a really cool project. Again, if you liked what you saw and you're here at the end, so hopefully you did, you click like and subscribe and get notifications, and we'll let you know every time we post something to the YouTube channel. If you did like what you saw, pick up that issue of GeoStrata, the latest one, the October-November issue on geostructural engineering. And in just 2 weeks, we'll be in Pittsburgh for the Geostructures Conference, where you can get even more of this. And we'll be live streaming some of those plenaries from the conference as well, so you can get a little taste of it, even if you can't make the trip to Pittsburgh. But you should still try to be there with us. We'd love to have you. Our next live stream will be 1 week from today. It will be Geotechnical Frontiers Sneak Preview #1. John Wallasick talking about the Corvette Museum sinkhole remediation that happened in 2014. So you get to hear from a guy who knows a little bit about that stuff and knows a little bit about cars. You're going to want to be there. You can sign up for that and all our other live streams on our Eventbrite page. Thanks again to all 4. This was our first GeoStrata Extra with 4 interviewees. We did well. We had fun. Thanks everybody for participating, and we will see everybody very soon.